In this lesson, we're studying the area of a sector of a circle. A sector is a small piece or a fractional part of an entire circle. I've drawn a sector here. I have two radii going out to the circumference of the circle. I've outlined the arc length, which hopefully you've already studied in red. It's related to this specific sector of the circle. So the whole sector is this entire piece. And so sometimes you need to calculate the area of a sector of a circle. And these formulas, these shapes occur in higher math. You'll see them a lot. And you'll deal with sections and sectors and segments of circles in trigonometry, higher math. But you also see them in building and construction and trades. Sometimes you'll see circular parts of buildings. A great example is old castles that had turrets, like on the corners that were circular pieces, but not entire circles. They were segments. They were usually larger segments, not a small piece, but like what would be more of a sector. I'm using that word incorrectly. It's a sector when it's like this pie-shaped piece. This other piece that I've not really highlighted, so this entire piece would also be a different sector of the circle, and that's kind of what you see like in the turret of a castle. It's part of a circle and almost an entire circle, but not a complete circle. So sometimes you need to work with these odd shapes. Fortunately, they're not difficult to work with, and they're obviously closely related to what you already know about circles. We know the area of an entire circle is pi r squared, but I want to find, so if I'm finding the area of only a piece of it, then I want to know what fractional part that is, and if I multiply that fractional part times the entire area, I'll have the area of that small piece. Well, the fractional part is related to, we know that a circle has 360 total degrees. So how many degrees are represented in this small fractional piece? And that's usually, we use a symbol theta. We use other symbols for angles, but a common one in formulas like this is theta, which represents an unknown angle. Fortunately, we know an angle for the problems we want to work out, so let's just jump into it and work a couple of examples. In the first example, we're going to use theta equal to 120. So you might say the angle that I have drawn here is much smaller than 120, and if you measured it, you would be right. But always remember in math to use the number that's given, not what it looks like. But yes, 120 would be bigger than this because it's larger than 45 degrees, larger than 90 degrees. So, but at any rate, I just wanted you to see what a segment was, and our actual angle we're using for calculation is 120 degrees. We need to know something else. We need to know something about the radius. And in this example, the radius is 4 centimeters. So we're ready to move on with the calculation. So the area of the sector, I probably should write sector area, is not the area of the entire circle, it's just the piece. So the sector area is equal to pi, and we're going to use 3.14 for pi. The radius is 4 centimeters squared, and then the fractional piece is 120, do that kind of big, out of 360 degrees. So that's what part of the circle we're finding the area of. Of course, this formula you'll recognize would give us the area of the entire circle times the fractional piece of the circle we actually want to look at. We only want to know the area of the 120 degree piece of the circle. So now what's left to do is the math. This fraction, since we're working with a decimal, you can convert it to a decimal. It reduces nicely to like a 1/3, but let's go ahead and go 3.14 times 4 centimeters squared is 16. 4 times 4 is 16 centimeters squared, times this reduces to 0.333. 120 divided by 360 will give you that. It also reduces nicely to 1/3 if you'd rather use that. It'll all end up being a decimal in the end, so this is fine. And when you plug it into your calculator, your final answer is 16.75 centimeters squared. Actually, the final answer is like 16.746 and goes on and on and on, so I rounded to 2 decimal places. Often your curriculum or your teacher will tell you where to round them, so that it's an appropriate measurement. I rounded to the nearest hundredth or to the second decimal place, and my answer is 16.75 centimeters squared for the area of that sector. Let's do another example. These are also not that difficult really. So all mistakes made in these are in the calculation every time. Most people can follow the formula pretty well, and it really is a straightforward formula that makes a lot of sense. So that helps, but be careful with your calculations. Let's do one where the angle is 90 degrees and the radius is 12 feet, so we got a pretty big circle this time. Segment is only 90 out of 360. Radius is 12. We need to know the radius. We're going to leave pi in terms of pi for this example because we want an exact answer. So area equals pi times radius is 12 feet. We're going to square that. And then the fractional part is 90 out of 360. Again, you can turn this into a decimal, you can reduce it, there's a lot of ways to go. But let's go ahead and finish the math here. Excuse me. Area is pi times 12 squared is 144. Feet squared is feet squared. So 144 feet squared, you may need to plug that into your calculator. You may know 12 squared. And then 90 over 360, I can start to reduce it. I can turn it into a fraction, or turn it into a decimal. I'm going to go ahead and reduce this one because I know dividing by 10 right away helps. And then I see a relationship between 9 and 6 immediately, so it's 1 over 4 reduces to 1/4, which is, as a decimal, 0.25. So either one would work. When you finish the calculation, you're going to end up with area equals pi times 36 feet squared. And again, the proper way to write that is 36 pi feet squared. You always put, and this is just simply structure for communication's sake, this is not a wrong answer, it's just not the common way we do it. So you reverse the order, put 36 times pi feet squared. Since multiplication is commutative, I can switch the order of those two without affecting the outcome. Final answer is 36 pi feet squared. So not that difficult finding the area of a sector of a circle. So go ahead and practice these. I'm sure they'll go really well for you.